Welcome Algebra 1. This lesson's on graphing quadratic functions in vertex form. Let's begin. The essential question is, what are key parts on a graph of a quadratic function? So this is what a quadratic function looks like. This is the we call this the parent function, y equals x squared. So this is the graph of y equals x squared. Some key parts you want to know are what a vertex is. The vertex is the maximum minimum point. So it's kind of like the one that's the lowest point or the one that's the highest point. In this case, like if you have this U shape, it's the very bottom of the U shape. And the coordinates of the vertex, you're going to write as an ordered pair 0, 0. The axis of symmetry is another key part. This is an imaginary line that we use to divide the shape in half. We call this shape of the quadratic function a parabola. So that's the U shape, a parabola. So this axis of symmetry divides it in half, and the equation for this one, axis of symmetry, is x equals 0. Now there's two different ways we have forms of quadratic functions that we can graph from, standard and vertex. This video is on vertex form. Standard form is in the next video. In vertex form, here is what the equation looks like. Y equals a times the quantity x minus h squared plus k. So what does this a, h, and k stand for? Well, the h and k stands for the vertex of the graph. So if I had an equation y equals 2 times x minus 3 squared minus 5, the vertex is going to be positive 3, negative 5, and be plotted right here at positive 3, negative 5. Note, this says negative 3 here, and a lot of people will think, oh, it's negative 3, negative 5, but it's not. Because the formula says x minus h here, it's the opposite of the h. So if it's the opposite of this number, so if it says negative 3 up here, h is going to equal positive 3. And whatever number's on the outside, it's going to be whatever that is for k. All right. The other thing, what does that a value do? It actually stretches and compresses the function. So if your a, the absolute value of the a function, the a value is between 0 and 1, it compresses it, so it makes it a kind of fatter, wider function. If the absolute value is bigger than 1, it stretches it, makes it really tall and skinny. So these are the graphs of 1/4 x squared is kind of wider than if you just graphed x squared. It would kind of, graph of x squared would look like this. And if you have a graph of 4x squared, it stretches it because the regular graph of y equals x squared just looks like that. So it stretched it, made it skinnier. Now a value can also reflect the graph. If the a value is greater than 0 or it's positive, the parabola shape is going to be upward. So it's like, it looks like a U. So this is the graph of y equals positive 2x squared. Looks like a U shape. If you had the graph of y equals negative 2x squared, it's going to flip it downward. It kind of looks like a sad face. So this is when it's negative. And it's going to be negative 2x squared. All right. We also have another thing called translation. So vertical translation is moving the graph up and down. And this happens when you change the value for k. So that's the number on the outside. So when your k value is positive, like plus 2 or plus 3, k is actually moving the graph up. So the graph gets moved from this blue shape right here up to the red shape. The blue shape, if I did just the equation for the blue part right here, is y equals x squared. And the red shape is y equals x squared plus 2. That plus 2 moved it up 2 units. So it moved up 2 units. Now for the graph of y equals x squared minus 2, we're moving down 2 units. So when it goes down 2 units, we go from the blue shape, y equals x squared, down 2 units. And so like this vertex point, instead of at 0, 0, it's at 0, negative 2. All right, next thing. Horizontal translations. This is moving the graph left and right. And this is changed based off of the h value right here. So this is a little confusing. If the h value is positive, you move to the right, and h value is negative, it moves to the left. However, remember that when you're looking at the equation, the h is actually the opposite of this number. So if you have an equation x minus 3 squared, that means my h value is positive, and our graph moves to the right 3. So it's going right 3. And if we have the graph of y equals x plus 3 squared, we're actually going to move to the left 3. So x is x plus 3 squared. So x plus a number moves it to the left. X minus a number moves it to the right. It's kind of a little bit backwards there, but just needs a little practice, and I think you'll get it. So how do you graph a quadratic function? Because that's the whole point of this unit. So I wrote down the steps. The first thing is you want to plot the vertex and then draw the axis of symmetry. So I'm looking at my graph right here. I want to graph the equation y equals x minus 3 squared plus 1. I know my h value is going to be positive 3 and my k value is positive 1. So my vertex is at the point 3, 1. So I'm going to plot that point 3, 1 down here. And I want to label it 3, 1. And then draw the axis of symmetry. The axis of symmetry goes through that point, and it's going to be x equals 3. It's a line that goes through the vertex, a vertical line. So I'm going to draw a vertical axis of symmetry through that point, dashed line. Now, I want to plot 2 points on one side of the vertex. So I'm going to make this table here, xy table. So use your xy table. And I started my first point, 3, 1. Now I'm going to put 2 points on one side of the vertex. So I'm going to pick 2 values. I'm going to say pick 2 x's. So you pick 2 x values here. And you can pick them to the left or right. It doesn't matter. I'm going to pick to the left because the numbers are smaller. So I'm going to pick 2 and 1 for x. You could pick 4 and 5. It doesn't matter. And now, as you pick those points, you've got to figure out what the y value is. So I'm going to plug in that value. So for x is 2, you get y equals 2 minus 3 squared plus 1. 2 minus 3 is negative 1 squared plus 1. That's going to be positive 1 plus 1, which equals 2. So y equals 2. For x equals 1, you get y equals 1 minus 3 squared plus 1, which is negative 2 squared plus 1, which is positive 4 plus 1, which is 5. So y would equal 5. Now that I got those 2 points, 2, 2, and 1, 5, I'm going to plot them. So 2, 2 happens right here. I'm going to label that 2, 2. And 1, 5 happens right here. So I'm going to label that 1, 5. That's step 2. Now step 3 says mirror those 2 points on the other side of the axis of symmetry. So this is like a mirror. I want to reflect every point. So this point right here at 2, 2 is at 2 up, but it's 1 to the left. So I'm going to put it 2 up, but 1 to the right. So I reflect it right there, and the coordinates of that point are 4, 2. Now for the other point, it's 5 up, but 2 to the left. So I'm going to go 5 up and then go 2 to the right. So I'm going to draw that point and go, and that's at 5, 5. So I mirrored 2 points. And you need 5 points to graph a quadratic so you see the parabola. You need enough to do the U shape. Now I'm just going to sketch this curve. I know it's going to look like a U. So make sure you go through all the points and do a perfect parabola. Make sure you put arrows on the tops. And there you go. That's a perfect graph. Let's try some examples. Pause the video. Okay, I want to graph this. So I got to find my vertex here first. My vertex is going to be the h and k. My h value is here and k value is here. The h value is going to be opposite of this number, so h is positive 1. And my k value is going to be negative 1. So the vertex is at 1, negative 1. I'm going to plot that point 1, negative 1, label it, and then draw an axis of symmetry going through that point. I'm going to say my axis of symmetry AOS is at x equals positive 1. Now, I want to plot some more points. So make my table. And I've got my first point already, 1, negative 1. I want to plot 2 points. I'm going to choose, I'll go to the right. Why not? I'll choose 2 and 3. So if x equals 2, what's y equal? Well, I get y equals 2 times 2 minus 1 squared minus 1, which is going to equal 2 times 2 minus 1 is 1 squared minus 1, which is 2 minus 1, which is 1. So when x is 2, y is 1. For x is 3, I get y equals 2 times 3 minus 1 squared minus 1, which is 2 times 2 squared minus 1, which is 2 times 4 minus 1, which is 8 minus 1, which equals 7. So y is 7. I'm going to plot those points. So 2, 1 is right here. I'm going to label it 2, 1. And 3, 7 is right up here. I'm going to label that 3, 7. And now I want to mirror those points. So we'll mirror it on the axis of symmetry. And that means I'm going to have a point right here and label it 0, 1. And it's 2 left right here. So 2 left would be right here. And negative 1, 7. Now that I got my 5 points, I'm going to draw my perfect sketch. My perfect parabola going through all the points. That is beautiful. All right, next one. Pause the video. Okay, this is just asking how it's translated. So how is the graph going to move from the parent function y equals x squared? Well, the difference here for the first one is I have this minus 5. What is the minus 5 to? That's my k value. And that minus 5 actually moves the graph up and down. Since it's minus 5, it's going to move it down 5 units. That's all you need to say. For the next one, I get x minus 4 squared. This is the h value, and that does the horizontal translations. When you have x minus 4 actually moves it to the right 4 units. Next one. All right, let's try this one. What are the vertex, axis symmetry, max, minimum, domain, and range? Okay, so easy. Let's find the vertex first. That's the h and k. My h is going to be positive 4. My k is negative 2. So my vertex is going to be at 4, negative 2. Axis of symmetry. Axis of symmetry is just a vertical line at the vertex, and that's going to happen at x equals the x value of the vertex, so x equals 4. Next one we're going to find is the maximum or minimum value. And I didn't do that directly, but maximum or minimum, what do we have here? Well, when you have a graph that's a positive a value, you know you're going to have a shape that looks like this, like a U. So your vertex is actually going to be a minimum value. So it's going to be a minimum. And the maximum minimum is always at the vertex, and it's the y value. So the minimum of this parabola is going to be, I'm going to say, negative 2, because that's the y value of the vertex. Domain and range. The domain is all your x values. And because the parabola goes to the left forever and right forever, domain is going to be all real numbers. Now let's do the range. So the range, it's going to be based off of the vertex here. Since the minimum value is negative 2 for the vertex, our range is going to be every number that's above that. So our range, we can say, is y is greater than or equal to negative 2. That's it.